Hello, my friends. I am here at Hainbuch today in snowy northern Wisconsin. I am a little bit cold, but I am having some fun. So, as a part of that fun, we're gonna go inside. We're gonna play with some really great tooling in there, and we're gonna play in the snow a little bit too. Okay, that's way colder than I thought it would be. Oh, welcome to Hainbuch. Let's go inside and have some fun, shall we? Hello, my friends. I hope everyone is doing well. Today I have the great pleasure to be in Hainbuch, America, here in Wisconsin with my friend Michael. And we're gonna play with this cool contraption here called Today, Tonight, and Tomorrow. And Michael's gonna take us step by step on what exactly this is, how it works, and how user-friendly it is for everyone out there.
Yes, thank you, Tony, for being here. It is our Hainbuch modular system, Today, Tonight, Tomorrow. A lot of you might know it by that. But a lot of you are familiar with the collet chucks, which you can easily change out. In about 10 seconds. From there, Hainbuch took it a step further. Most collet chucks stop with the collets. We call them clamping heads. We can take this chuck and very easily insert an ID mandrel. The ID mandrel is extremely powerful, sometimes underestimated. Kind of just lay it in there, put some bolts in, you're ready to go. I can do this in about 2 minutes, on a machine, so it's really flexible. Or if you want to expand your diameter, you can put a jaw module in here. And again, a few bolts, centering, and you're ready to go. I want to bring this one back again because I want to call out the Centrex ring. I call this the heart of Hainbuch, because everything with Hainbuch is about accuracy and changeover and flexibility. This allows for that, because when you have this taper here, and you got a vulcanized rubber ring, that is pulled into the taper, that's where you get your accuracy. And more importantly, your rigidity. So, beauty of this whole system too is you can apply it to your stationary device. So if you have a mill going, these will go right in there as well. So just on that alone, you can see how flexible this is, and it's all about flexibility in today's manufacturing. Changing over from one application to another, 2 minutes or less, you're ready to go.
So Michael, one thing you touched on briefly, but I'd really like to reiterate, is the fact that we can go from mill to lathe and lathe to mill with these interchangeable components, right?
That is correct. As long as you have the same size devices, so these are both 65 millimeter chucks. This one would go stationary on a mill. Here's a turning center or lathe. So then you can easily take this jaw module onto the lathe, take it off, put it onto the mill to hold something stationary, or with the same thing with the Mando Adapt, which is the ID clamping. And clamping heads all are interchangeable as well, as long as it's the same size.
To me, this is important to reiterate because, I mean, we're talking flexibility and adaptation, right? When
Yes.
you can do anything from any position on any machine, whether it be round bar or square stock or whatever it might be, and I can throw that into a lathe or a mill, now we're utilizing our machines to the full capacity of what they're able to do.
Exactly. Just think of, a whole line of lathes or mills, and you have some of these components on it. Just go to your shelf, pull out your next adaptation, and you're ready for your next job.
Yeah, I mean, I've run a lot of mills more recently than I have the lathes. Obviously, we talked about lathe experience, but something this size on almost all the mills that I've run, I could pop one of those on there, a couple of quick change vices to pull it on and off, and now we're really getting moving, right? Now, the main goal is to keep that spindle turning, whether it be on a lathe or a mill. Just keep it going. That's how we make money. That's how that ROI comes in. Something like this, to me, is brilliant.
Yep, this keeps the green lights on.
Wow, Michael, that's really impressive. I want to go over a few topics that you mentioned in a little bit greater detail. I think the three-jaw chuck has been around over a century, right? We've been playing with this thing for a long time, so everyone's familiar with that. But having this quick change system it looks really user-friendly. So guys, I'm gonna give this a go in a little bit, and I just want you to know, I've never done this before, so comment section, peanut gallery, have fun with this one. But what I wanna focus on quickly before we get into that is the rigidity here. And if I may share a story, at the beginning of my career, I worked at a jewelry manufacturing place, and we had to ID clamp everything. Every single anniversary band that goes on your finger was ID clamp. And we had it slip off all the time, and we had to over tighten, and we were breaking either, the collet situation is what it was on these older machines, or the ring was slipping off, and we would have to scrap a few, and we're talking gold, platinum, silver. So when we're talking about the rigidity here, that's a significant component for most people.
Yes, the power of that ID clamping, it astonishes people when they see it, because they just don't believe it's going to hold. And when they get it on there, it's fabulous. We have specific gear mandrels for gear cutting. Not part of the system, but we have a whole line of gear mandrels just because of that power is so significant. And again, it's with the vulcanized rubber ring in there that makes it pull down on a taper, so it's flexible, it expands. You're not going to move that.
And this rubber that we've mentioned a few times and a lot of different components, this is a real significance at Hainbuch, right?
Yes, it is. That vulcanized rubber is a very special recipe that nobody knows. It's like the secret herbs of Kentucky Fried Chicken. Nobody knows that recipe. So, and we're not going to let anybody know, because that's what makes Hainbuch unique. And that's why I call that ring the heart of Hainbuch, because it makes everything beat. It makes your job shop beat a little bit better.
And something else, and that's really cool. I wish I was a chemist that was creative enough to come up with that kind of thing. Yep. But something else that pops into my head, I keep jumping from subject to subject because I'm fascinated by this kind of stuff, guys, is the precision, right? So when we're switching one of these, whether it be the 3-jaw chuck or the ID clamping or one of these guys over here, when you pop it in, you don't need to touch off again and again every single time. You're within microns, right?
Yes, no need to re-indicate. So you can pull back, go from a clamping head or a jaw module within under 10 microns is usually a safe bet. We've seen it under 5, and it's even getting better. So as the R&D keeps developing and keeps expanding, it's incredible what they're doing in Hainbuch, Germany.
Right. Well, again, back to my somewhat experience in the lathe world, when we popped on a 3-jaw chuck and we had to put another, whatever situation on there and then pop that 3-jaw chuck back on, it took us hours, sometimes longer than hours, depending on what kind of setup it was, to get it back to aligned. And if I'm being real honest, which you guys know that I always am, when we had somebody who wasn't quite an expert at setting this thing up, the vibration that would come from this thing spinning at 1,000 RPM or 2,000 RPM, it was scary. Yes. I actually saw one of these chucks fly through a piece of plexiglass one time, come zipping out of the machine because the person setting it up was not a professional, and it flew out. It was one of the scariest moments of my life. So thank you for keeping these things precise and allowing us to switch them out so easily.
And the beauty, and you're talking about centrifugal force, because when a 3-jaw chuck starts to rotate, the centrifugal force is going to pull everything outward. With the collet chuck, it's encapsulated in there, so it significantly reduces that centrifugal force. So you can turn at a higher RPM, you get better surface finish, longer tool life, more rigidity is the answer to that. So it's just a fabulous setup.
Oh, to reiterate what you just said, rigidity is so significant.
Yes.
Just like content is king for marketing, rigidity is king for manufacturing. And we're not just talking about the jaws needing to be hardened steel. We're not just talking about this having the extra clamping force or expansion force, right? We're talking from spindle to cutting tool, the cutting tool itself needing to be rigid. Rigidity adds depth of cut, feed rate, longer tool life, better finishes, longer machine life. Everything is all inclusive when we're talking rigidity.
Exactly. Rigidity and flexibility. And I think those are the 2 key components that we really focus on and excel in.
Well, Hainbuch has been doing this for a long time, and for sure you guys are, the leaders in this type of technology. Thank you for educating me on this. Guys, I'm going to give this a try. I think it's going to be so user-friendly, I'm going to knock it out of the park. But we were going to see. So, Michael, let me give this a go. We take this clamp here. I'm gonna set my microphone down. Let's go here. Find that smooth point.
Done.
Seconds. First time ever. Seconds. Anyone can do this, guys. We can do this. Wow.
Beautiful.
It really is that easy, and it's just a matter of seconds. God, I wish I could have had this 20 years ago.
Yes, and that's what, you know, 3-jaw chuck users, when they make the switch, they all say that. I wish I would have done this years ago. So, you know, just keep an open mind, and I think people will come around.
Yeah, return on investment would be, you know, it's nothing when you think about the investment in this quick change system.
And again, all about flexibility.
Mike, I really appreciate your time. That was fun. I didn't realize how easy it was. You've educated me today. Thank you for being a part of MTD.
Yep.
And guys, thank you for watching. I hope you've enjoyed it and learned a little bit as well.
Thank you, Tony.